Alright, so 2, 3. Start off this way. I have given you every one of these on 2-1. We actually, if I broke out my 2-1 notes, these were the exact last 3 questions we ended with on 2-1. The derivative of 7, anybody remember that off the top of their head? What that was? Here, let me show you the graph of, and why it was. Good. Alright, what does the graph look like of 7? Straight horizontal line, and what's your slope of that horizontal line everywhere? 0. Alright, look at the next one. Your graph looked like this. I hit at -2 and I went down very steep, so it's a negative slope and it's real steep. Bless you. Alright, my derivative there, what's your slope always? -8, so that's my derivative. And again, we already taught all these. This one, f prime of x was 2x plus 1. Here's what the graph looks like. About something like that, parabola. Okay. My slope varied. So one of the connections that I wanted to make right in the beginning was slope is 0 because it's straight horizontal. Slope is -8 because it does not change. And your slope has a variable in it because it's constantly changing. It's going from negative to 0 to positive. Alright, there's where your horizontal tangent would occur, right there. Alright, what I did was I gathered stuff, and I'm sorry, Jackson, you just asked about, for me to work that one out and where that derivative came from. I will do that in just a little bit, okay? But, all of these I grabbed from your last 2 worksheets, 2-1 and 2-2, either from notes in class or from the worksheet. For instance, this was on 2-1 example, derivative was -8. Alright? This was from 2-1 example, 2x plus 1. Okay? This was from a worksheet, derivative's 2x. This was that one that Jackson was asking about. This is a -12 over x squared. And I'm going to skip this square root of x plus x minus 3 for just a second. This one right here is a 2x minus 5. So here's what I want to do real quick, and then I'm going to see if you guys can come up with this. Those of you that do not already know this, or were not in calculus last year, okay? Give me a polynomial, in other words, something that looks like this, okay? Just any random one, any numbers you want. What's your favorite polynomial?
X to the 9th minus 4x plus 4.
Oh, that's a wonderful polynomial. Alright, the derivative is 9x to the 8th minus 4. 9x to the 8th minus 4. Okay? Alright. Any theories on how I could do that quick? How could I connect those numbers? Hold on. Come right back up here. What's an obvious connection between this and my answer there? It's the -8, okay? Then we get a little more confusing down here. This didn't even have an x term. Alright? Alright. What? Okay. Okay. So look, let's make a rule that would work on this, and that would work on this. Where was there a 9 here, and then I ended with a 9? Where was there a 2 here? Okay? So I'm taking the exponent and moving it forward. Alright? Well then, how do I go from an x squared to an x? I take 1 away. How do I go from x to the 9th to x to the 8th? There is your rule. N x to the n minus 1. That is the rule. Alright, let me give you another one. Hold on. And then let me show you on this square root of x minus 3. Alright, well I had 2x terms. What was the power of this x? What's 1 times -4? -4. And then when I take 1 away from 1, I'm left with 0, no x's. X to the 0 power is just times 1. Alright, let's try another one. Here. Let's do 1/3 x to the third minus 2 x squared plus 1. Let's do that one. I'm running out of room.
I know the answer.
Hold on. Now I got somebody that's gonna help me through it, because they need to know that they are smart. Use smart.
You special.
Alright, Bailey.
Oh,
So 3 times 1/3.
What?
3 times 1/3.
1.
Use smart. What happens when I take 1 away from x to the third? What's 2 times -2? What happens when I take 1 away from x squared? X to the first. The derivative of any constant, just 0.
So it's just 1x, just x squared minus 4x.
X squared minus 4x?
Do you believe in magic?
What's that?
Why did you forget about the last one?
What is the derivative of any constant? Oh my goodness. So the derivative of any constant is just 0. I forgot to make this first big point here. Sorry. Because think about this. If I change that as like f of x equals -4, what's your slope of -4? What? Just 0. F equals 1,000,000. What's the slope of a straight horizontal line up at 1,000,000? 0. Any constant is just 0. That's why it disappears. I am sorry I skipped over that. Got so excited about the derivatives, I skipped that. Alright, so here's your key point. Hold on. Here's your key point. Get this down. Because, again, we're not just going to do the exact, like, do number 1 now. Everybody do number 1. Shh, do number 1 on your own. On your own. On your
I'm gonna
own.
beat all of you.
Hold on. Shh. Hold on. You were leading me through the other one.
Wait, which one?
2 times -3.
Oh, yeah.
Okay. X to the first plus 2. Multiply, take away power. Multiply, take away power.
I feel dumb already.
Okay? Alright. Come back up here. Alright, let's get a little funky.
Oh, man.
12 over x. Here's your key. No, stop. Here's your key. You've got to write this as x to a power. So, that is 12 times x to what power?
-1.
Good. Now, should be easy. What's -1 times 12? And what happens when I take 1 away from -1? Which is -12 over x squared.
That makes
Magic.
Okay? So, the square root of x minus 3. Square root of x minus 3. Let's write that as a power. X minus 3 to the 1/2. Okay? Oops, hold on. Alright. Multiply. 1/2. X minus 3. Subtract the power. What happens when I take 1 away from 1/2? Now, AP, hold on just a second here. For everything that we're going to do now, I just want you to get used to doing that. What's on the screen right there? Leave it in that format. Technically, that is the same thing. I don't have a lot of room here. But it's 1 over 2 square root of x minus 3. Moving that x minus 3 down to the bottom and rewriting it with the square root sign. But everything we're going to do now, just leave it like this. Okay, do not worry about converting it over to anything. I just want you in the habit of moving the power, multiplying the power, subtracting 1. Multiplying the power, subtracting 1. Alright? So, try to do number 2. Let's go down to the bottom. We're done with the top. Down to the bottom. Alright, now let's start doing it. X to the 2/3. If you were trying to do this with the definition of a limit, definition of a derivative, this sucker would get really hairy, really nasty, it'd be a pain. But if you can just do the power rule. Multiply the 2/3, so f prime is 2/3 x. What happens when I subtract 1 from 2/3? Alright, and you're gonna have to get good at working with fractions. You will have to get good at that, you'll have to do that in your head. We'll need to know that. Alright, so the trick to 3, 4, 5, and 6, all of these are not bad. It's just they're not presented in the nicest, neatest way. So, let's rewrite all these problems real quick and then I'll have you do the derivative. Alright, square root of x. I don't want to write it like that, I want to write it as x to a power. So, square root is x to the what power? Cool. Alright, so hold on just a second, let's write them all. Number 4. 1 over x squared is x to the? Good, negative 2. Kind of tricky here, we're combining both those ideas together. What's 1 over square root of x? Good. Alright, and then finally, 6 looks okay, everything except that last little part. Just scratch that little part out and write it x to the negative 2. Now, you guys do the derivatives of 3, 4, 5, and 6. Now they're not bad problems. How they presented them in the beginning, trying to do it with the definition of a limit and all that, or definition of a derivative, that would get pretty tricky. But, if you can rewrite them as a power, these really become pretty easy. Alright, so take a second and do that. Okay, let's go piece by piece. Number 3.
I'll get this report.
Keep going, keep going. I'll give you a second, I'll give you another second. Let me give you a second. Get them all. Get them all.
Can they get some help?
What?
We learned the constant rule in physics.
Yes, we learned that in physics, day
Oh yeah, she said something equals 0. She told me that.
Yeah.
She said it really loud, but she didn't know what she wanted. You know, she's talking about it.
Yeah.
She's worried a bunch of crap.
Probably. Yeah. Which I think she's smarter than she is.
But that's what she does. I don't know what she's talking about. She doesn't know what she's talking about.
Alright, so 3. When you multiply the power, what'd you get? 1 half x to the? Good.
Nice.
1 half x to the negative 1 half.
Oh.
Okay? 1 half x to the negative 1 half. Multiply, subtract power. Give them very repetitive. Multiply, subtract power. Alright, number 4. Multiply. Subtract the power. Got it. Leave it like that. Yes, you could rearrange that as like negative 2 over x to the third. Just leave it. Number 5. Multiply.
Wait, we just leave it like that?
Yep. Negative 1 half x to the negative 3 halves. Multiply it, subtract the power. Alright. Number 6. You got 3 parts to this one. So, you got 15x to the 4th. Negative 2x. Positive 2x to the negative 3.
Wow.
15, subtract it, 4. Negative 2, subtract it, 1. Negative 2 times negative 2. Positive 2, subtract it, negative 3. Alright? There's what I'm teaching. Flip it over. Here's what AP does to you. Alright. They make you review Algebra 2 stuff. Algebra 1 and Algebra 2 stuff in the middle of it. So, I've taught you the concept. That's the concept you're learning today. I got one other little thing to put on it. But now we got to review some algebra. Okay, so there's a few things going on here. Remember, my goal, look back at this, my goal is if I can rewrite something in the power form, 12x to the negative 1, then it's easy. You multiply, take away 1, okay? Multiplying two numbers and subtracting one number that's not hard, alright? But, I got to write it in that form. So, with this, let's rewrite it. How can I rewrite cubed root of x? Good. Alright, now there's a few different ways to think about it, but here's what I think would be the easiest way. Is, I've got an x to the 1/3 times x. That 2 right there, I can rewrite as negative 2. Multiplied times x to the negative 2. Plus 5x to the negative 3. Now the 5x to the negative 3 is not the problem. It's I got to combine these together. And again, this is 100% algebra 2, algebra 1 and algebra 2. I taught this in algebra 2. When you multiply x to the 1/3 times x to the negative 2. Are you multiplying the 1/3 and the negative 2, or are you adding them? You're adding them. So now on top of adding two numbers, doesn't sound bad, you got a fraction in an integer. I wanted to give you this about as nasty as it could get. So I got to do, in my head, I'm doing a 1/3 minus 6/3. I'm thinking about the 2 as 6/3. Then that would be a negative 5/3. But now that I got it written like that, that was the hard part, was rewriting it to something that looked familiar, that I know how to take the derivative of. Now I can actually take the derivative of it. It is negative 5/3 x. What happens when I take 1 away from negative 5/3? Good, negative 8/3. Dang it, that's supposed to be an 8. And then a negative 15x to the negative 4. Okay? Alright, now tomorrow we're going to learn what's called the product and the quotient rule. Okay? But, we don't know that yet. So in number 8, let me just stress this. You cannot find the derivative of this. Find the derivative of this and then multiply them together. It doesn't work. And I will explain in detail why it doesn't work for tomorrow. For right now, all you need to know is if you multiply f of x, so I take x to the negative 2 times x to the 3rd, that's x. If I multiply there, I got negative 7x to the negative 2. If I multiply here, I got plus x to the 3rd. And if I multiply there, I got negative 7. So I'm doing distributive properties straight from algebra 1. Now they ask me some harder stuff with negative powers, but otherwise that's just FOIL. Now that I made it look like that, now I can take the derivative. So you guys figure out what the derivative is. That's, again, what I'm teaching that's new today. Take your power of x, multiply, subtract the power, subtract by 1. Okay, go through and do that derivative. Alright, we gotta start moving. So I got 1 plus 14x to the negative 3 plus 3x squared. Got to put anything there? Yeah, any constants, just 0. Got it. There's your derivative. You good? Good.
You think it's easier to do that or do the quotient, not quotient, product one?
Probably that. Either way. Probably product, but
We got pretty used to the product. Though,
yeah,
so.
probably product. Alright, number 9. Okay, again, they just give it to you weird. What does that negative 1 mean? What if I said, what is 1/2 to the negative 1? Okay, flip it. It's 2 over 1, which is just 2. So if they do this to the negative 1 again, this is just giving you a problem that the algebra behind the stuff is the harder part, not the calculus. So the negative 1, I gotta flip it. 3x to the 4th minus 2x all over 4x to the 3rd. This is the problem that some of you guys missed on that last test. We had like sine, we had x plus sine of x over x. You've got to divide both things. If there's a binomial on top and a monomial on the bottom, they both get divided. So this is 3/4 x, because x to the fourth over x to the third is just x, minus 2 over 4 is 1/2. That's a little trickier. How many x, what x do I have there? X to what power? There's 1 on the top and 3 on the bottom. Kind of an x squared. Not exactly though. Where is that squared? It's on the bottom. On x to the negative 2. Now that I wrote it like that, now it's not that bad of a problem. Again, it was getting it to look like that. That was the harder part. And now I can figure out what the derivative is. So it's 3/4. It's plus, just 1. 1/2 times 2 plus 1 x to the negative 3. Okay? Alright, just want to expose you to this real quick. First, second, third, fourth derivative. You can take the derivative of a derivative. We're going to do that a whole bunch next chapter. We're not going to do it much this chapter, but I want to tell you it can be done. Okay? Here's the notation for it. So f prime becomes f double prime, or y prime, if you take the derivative of it, is y double prime, or dy dx is d squared y over dx squared. It just means you take the derivative of the derivative, and you can keep doing that. So, derivative of this, you guys should be getting pretty quick at this, would be 9x squared minus 4. What's the derivative of that? What's the derivative of that? What's the derivative of any constant? Easy enough. Try the next one. Now we're having fun. Wyatt's feeling like a rock star.
Hey now, I'm just an all-star. I got the magic.
Power times numbers, subtract 1. Power times numbers, subtract 1.
Like, all this negative, like, really throwing me off.
That a negative times a negative is a positive?
No,
Whoa.
like, all the negatives and, like, all the powers and stuff. Like, when it makes me wanna flip it and put it here, then I just don't know.
Alright. Here you go. This is one of, there are many applications. This is one of them. This is one you've kind of already seen. Alright. But let's stress something here. Okay, now we can go back and we find derivatives really quick. Okay? Just in general, sketch the horizontal tangents. Okay, it's the same question I just asked you on that last worksheet. Visually, how many are there?
3.
Okay, one right there, and right there. Okay? Alright, I got it. I see them. Good to go. Here's the key concept. We're going to really expand on this, but this is the first day seeing it. Horizontal tangents occur when? Very simple. What's the slope of the tangent right there? If it's a horizontal line, the slope is 0. Well, how do we talk about the slope now of this function? How do you talk about the slope of it? What do we call that now? The derivative. So it happens when f prime of x equals 0. Huge idea here. This results in your horizontal tangents. Pretty simple idea, but a lot of applications with it. So now let's go use calculus to actually circle this, find the horizontal tangents, and there's a little trick question in here. I'll show you in just a second. So, if it's when f prime of x equals 0, let's find f prime of x. You guys all do that, and you can do it very quickly. (4x to the third minus 16x). But I want to know when that thing equals 0. I want to know when 4x to the third minus 16x equals 0. Alright, we're back to algebra 2. How do you solve that?
Magic
Factor.
factor.
Take out a 4x. Left with an x squared minus 4. What else do I need to do? difference of squares. Oops. So x equals 0, 2, and negative 2. Now, what people got wrong on the first test, and they're still getting wrong on the makeup test on some stuff, and it's a trick. I am trying to trick you on the test and the makeup test. Look at the question here, and star this. Because I'll tell you, the first time I took this test that you guys are going to take in a few weeks over this, I got this question wrong, and it's just one of those I wasn't thinking straight. Find the horizontal tangent. Is the horizontal tangent x equals 0, and x equals 2, and x equals negative 2? Now, those would be vertical lines at 0, 2, and negative 2, if I said that the horizontal tangent was x equals. Those are where the horizontal tangents occur. To actually figure out their actual value, you got to plug 0 into the original equation. So f of 0 is 0 minus 0 plus 2. F of 0 is 2. So y equals 2 is that horizontal
We're doing last call on football tickets.
right there.
Everybody's seating them when the bell rings, and they'll only have them for about 5 or 10 more minutes once the bell rings.
To figure out these two down here, plug in the 2 or the negative 2. F of 2 is 2 to the 4th minus 8 times 2 squared plus 2. So f of 2 would give you negative 14. So in other words, the actual equation for that one is y equals negative 14. Now I will tell you, if you plug in negative 2, you'd get the exact same result. But I wanted to make sure that I made this really obvious and stated this very clearly. If it asks for horizontal tangents, saying x equals is never going to work. If it said, I don't know, what's the x value that produces a horizontal tangent, well then it's 0, 2, and negative 2. If it said, where does the function, it's at x equals 2, negative 2. But if it says, what is the horizontal tangent, then you got to plug your x values back and actually get the y value. Okay? So, you were able to find a derivative quickly. Once you found it, you were able to use it to do something. Alright?